Okay, started.
All right. Hello, all, and welcome. Hello, and welcome to Python for Poets Part 7. And today we're going to deal with the if-else-if, or the else-if command, which I missed. Exceptions, which I didn't miss, but we haven't done yet. GitHub, and then we're going to go back through a bunch of concepts and things that need clarification based on the crowd, and if we have time, I'm going to go through an actual development thing of a poem writer. Somebody suggested that the other day. All right, so let's just start with GitHub. So why do you need source control? What's the point of source control? Well, basically, the issue is that your time is valuable and computer time is very, very cheap. And there's another thing, that the best way to do software development is by tiny, extremely strong steps. I often compare this to, I don't know if you've seen the movie The X-Men, the first X-Men movie, but or any of the X-Men movies. Well, there's a great scene where Metallo, he has a place that nobody else can get to because he can control metal with his mind, so he makes this metal like drawbridge appear. But that wouldn't actually work in the real world, and the reason is each one would sag a little bit, and if you had two or three, you wouldn't notice it, but by the end, you just fall right off. The only way that bridges and things really work is because they're extremely stiff. If you, I don't know, I've actually used this metaphor before, and you didn't have Meccano, you had something else like connectors or whatever it is. But if you try and make it something by bolting together things, if you start to bolt it together, it'll seem very, very solid, but if you make it something big, it'll be very, very wobbly. You have to figure out ways to make things really, really stiff, very, very solid. So one of the classic things that goes wrong with computer programs is, of course, you make changes and then you break something. So one of the things you'd like to do is to make all your changes as small as they possibly can. That's one thing. And to be able to keep track of each change you've made. There's nothing worse than you're about to deliver something and suddenly your code doesn't work. And you're like, well, what the heck? I have to get this done by tomorrow. Oh, God, I just should have stopped an hour ago. This happened to pretty well everybody in their life before source control. So what source control does is allow you to store each tiny step you make. And I can't emphasize too much that how small your steps should be each step. You literally I make the smallest change that's a whole thing. I test it. And I don't have to test it. The advantage of this mechanism, I don't have to test everything. I test the things every time. I test the things around this and then check it in, because if something goes majorly wrong, I have stored every step of the way that I have gone. So source control lets you store each step of your editing and working process. And that's why it's even if you're doing anything serious, I mean, it's an absolute must. You know, as Raymond just discovered. Some days your drive just dies. And this would not be a problem for me. Well, aside from the fact I want to make backups, it wouldn't be a problem for me in my development stuff because I check in. It's just my way of saying, okay, things are good now. You want to get to this known good state all the time. You want to have this known good state, and then if at some point you realize your state is not good, you want a way to do what we call forensics. Is the classic thing. In fact, so where you're literally going back and saying, what went wrong? So, when did I make this mistake? What was the specific mistake? Again, if they're tiny, tiny steps, you can easily figure out exactly what the step was where you went astray. And source control, like Git, gives you all the tools to do this. Now, there's actually multiple source control tools. There's many ones. There's in my life, I've used CVS, SCCS, Perforce. I've used a tiny bit. Subversion. I've used a tiny bit of that. In fact, there's one called Mercury. There's a whole bunch of others. I'm teaching Git because it's popular today. It has a lot of positive features, and it's pretty easy. It was also invented. Quick historical note: it was invented by Linus Torvalds, who wrote Linux.
Yeah.
He wasn't happy with the source control that was available at the time, so he decided to write his own source control, and the result is Git. I should add that only the scene Git is a morass of crappy scripts and C code, and is kind of notoriously awful to deal with the internals of. But you don't care about any of that. It works pretty damn well. And Raymond here has tried some of this and got a little bit confused, I would say, at points.
Yeah.
But it gets clearer as you work with it. And the reason that all of these things are a little bit confusing is having multiple people work on one project is just intrinsically somewhat confusing. You're going to have problems like one person made a change and the other person made a change at the same time in the file. And Git at least handles this in a much more mature way than earlier source control, which would actually, when I started to edit a file, I lock that file. So no one else can edit it. But I used to have problems in one company. They had this huge file. It was Market Vision. They had this file called mvlink.h 20 years ago or more when I was working on this. So you often had to make changes in that. But so everybody was constantly making changes, so you'd be stuck. You'd be stuck for a day. You couldn't actually... there's no power there.
Oh, okay.
Here, if you pass it over, I can give you some power from there.
You need me to move up?
In fact, look, I can just look even better. I have a Mac power supply just sitting here all ready to plug in. Even better. So these were things, and they were all of the old style ones like SCCS and CVS and all this sort of thing. They have the idea of a central repository that has this golden version, and everybody else has got a copy. They're kind of inferior. Git and other modern source control systems like Subversion
Oops, sorry.
do.
Sorry. John Jones here.
Git and these other modern things don't have this idea of a central repository.
Hold on a second, right? Keep going.
Yeah, sure. What's the chords? Don't have the central repository. It's a really nice thing because it's actually distributed. So one of the things is that if GitHub, the company, burnt down tomorrow, I would still have all the records of everything I'd done locally as well. Or if I wanted to, I could run a Git instance on a server somewhere and GitHub, and none of those things would be primary. The downside to this is you and I can go off in different directions completely.
Right.
So enough of this. I wonder how long he's going to be here. Let's pause this for 2 seconds because I don't want to lose him here.
Yeah, listen.
I'm going to have to trust your expert judgment. Right. So I just talked about the fact that GitHub is Git in general is decentralized. It doesn't have a single place that is the arbiter of truth. That's a big advantage because, if there's a crash somewhere, any individual person can retrieve everything, which is really nice. Or you can just do independent development. I'm like, okay, I don't want to deal with you anymore. Fuck you. Sorry about that for listeners at home. All right, so let's actually try it out. So let's supposing I'm going to do something. Let's just create a repo right now. So I'm going to show you how to do this with GitHub. There are multiple other people who provide this free service for you. And let me make this a bit big.
Zoom? Yeah, can you zoom?
Yeah, I'll zoom in everything and remind me when I don't. So this is I'm going to show you how to do it using GitHub. Everybody else has a similar way of doing this. Once you get the idea, it's pretty straightforward. Now, I generally start, just because it's easier, I start by creating what's called a repository on GitHub. Now, what a repository is just a collection of computer code, text, even images, binaries, whatever you want. It's just a bunch of files somewhere. So, first thing I do is I go to the repositories directory. This won't take very long. And I'm going to call this one, let's see, p4p. Let's do example. Very boring. An example for people to look at. Now, one of the things I generally do, and one of the time-saving features, is you can actually customize this to be a Python thing. So, I won't go into the great details here, but you should probably go down here and select this little option, initialize this repository, and add a git ignore, which I said as, oh, that wasn't very nice. I said it as Python. And what's git ignore do? This crap that Python generates behind the scenes, like these PYC files you may have noticed at some point, you don't want to check it in. It's of no use to check it in. It actually crowds everything up. So if you do that, it'll just says, okay, don't check this stuff in. Minor detail, everything will work fine. So then I click create repository. Voila. At this point I have an empty repository, or more or less empty repository, sitting on GitHub server. I have nothing yet on my machine. So let's start off by actually getting this item. And what I'm going to do is, there's a bunch of ways to do it. You can see there's 3 different ways here. I always do the command line one because It's easier. I always have a command line up. So let's do it. So what you do is simple enough, you copy this URL here and you say git clone. Voila. So there we go. And now I've created a file, a directory called p4p example. p4p example, I hope. And there's a bunch of stuff in there. I've got too many things starting with P. Voila. I can see a bunch of...
Sorry, can you make that... Yeah.
How's that? Yeah, that's much better.
Yeah.
Yeah,
If
please
it
keep...
can be a little bigger, sorry.
Sure, absolutely.
It is pretty small. So
How's
that's
that?
right.
No,
That's
very
yeah.
good. No, these are all good things. If you can't see what's going on, all my smarts are wasted.
So
You know
would
what-
you do us a favor and go
Yeah,
back
can we
through
go
that
back to
process
what-
again?
Yeah.
Oh, okay.
I couldn't
Oh, we
see
should.
any
Oh,
of
good,
that.
good. Well, let's go back to this then. Okay, let me. So here we can see this. I'm going to actually.
I saw this, but the other...
Let me quickly. Let's go and. Okay. Well, I'll call it p4px. Okay. So p. So what? Can you see this? Let me make it bigger even. How's this?
That's great.
Great.
Yeah.
Fantastic. So P for P test. Let's call it that. And again, so that's just the name. That's just a name, and I don't even have to work under this name. That's one of the nice things about it. It's completely flexible. I often have multiple copies of repos that I say, oh, I'm going to do some experimental work here, but here's my main thing. It's incredibly flexible, and it kind of is invisible to you, a lot of the work. So the one thing I'm going to do is do that, initialize with a readme here, and pick this git ignore. And that's just, as I said, prevents you from checking in meaningless files that are created that don't actually do any good for you. So I'm going to create this, and there it is. And then here in the corner on the right, you can see that it says there's a bunch of different ways to get things. Is this all visible?
More or less.
I can make it even bigger. We have it costs nothing. How's this?
Oh, that's nice.
Good, good. No, trust me, as my eyes go, I'm more and more sympathetic. So I said you can do it this way. There's 3 different ways to get it. These 2 guys will actually just download it through the browser. They're very easy. But I tend to do it from the command line because I'm just that sort of guy. Is this visible to you?
That's pretty good.
Pretty good.
Yeah, it's pretty good.
How's that?
That's even better.
Oh, right. So we're going to go back here, and I'm going to do git clone, and that means exactly what it does, make a clone copy of this, and then that long address that let me make this wider here.
So you making a clone of the repository that you just made?
Right, the almost empty repository.
Gotcha.
That's right. So I'm going to do this. It's going to say cloning in there. Bop, done. And then so now there's a directory with that name, p4p test, and then we can take a look at it. And it's got very little in there. It's basically got this readme that says nothing. All right, so let's start going. Let's do something. Let's actually make a file. So I'm going to... now, your editor will probably be different, but I'm creating a new file here, and I'm going to call it hello.py.
Oh, okay.
Right now, what's all this stuff there? You may ask, why did it suddenly pop up with this? I created a new file. This is all stuff. I'm working on some of the project right now. Every time I create a new file, it fills it full of boilerplate for me. Fills it full of all sorts of things that I need, but you don't. So I'm going to get rid of these. No, I'm not cheating you there. I'm just kind of, this is, my needs are more specific. So let's just do something here. We create a file, and we're going to say hello, and let's just say def hello, print hello world. All very clear? And then we'll do Python. Oh, actually, let's go into. I'm going to start a Python session here, and then we're going to do import hello. Then we do hello.hello, and it prints out that value. Pretty straightforward. Okay, that's great. So far, so here we go. This is vital work. I need to preserve it. Oh, sorry. This is vital work. I need to preserve it. So how do I do this? Well, one of the things that's again nice about Git is it doesn't automatically add anything to the repository. You have to tell it to do that. So there's 2 ways. You can do something like git. It's always going to be the git add command. I can either say git add hello.py, which requests that you add it to the repository, or I can just say git add dot. Dot adds everything that's missing in the current directory below.
Is that also the same on Microsoft systems?
Yeah, but Git, the program, if you're doing it with the command line, is identical everywhere. Completely identical. Another nice thing, it works on every system identically from the command line. There are lots and lots of graphical user interfaces, and but underneath it all, they're all doing commands like this. Nothing else. There is no other way to talk to Git. So let's do that. Now we can actually say, let's take a look. Git status. It tells me what's there. And can you all read this? Mm-hmm. So it says a bunch of information. It says on branch master. I'll explain that in a second. And then here we go. Changes to be committed. Well, it's pretty straightforward for this sort of thing. It says there's a new file called hello.py. Okay? So now I'm going to do git commit -m. That means message. Add a message add hello.py. If you don't add a message, then it'll bring up an edit and ask you for a message. That's probably how you do it.
It's been making me do it through Vim.
Yeah. So, but if you can just add a message on the command line, which I'm going to do.
And the option for that is -m.
-m. Very handy. So I've added this. So I've just committed this. Now, as I pointed out, this is a distributed version control system. So I've just committed this change, which means I've said, okay, I'm going to make this change. I meant it now. So, but this hasn't yet been pushed to here. If you take a look, this page, nothing has changed here since 4 minutes ago. This is a good thing. You don't want to necessarily make changes. You might want to make and save changes locally that you don't want reflected on the repository. Indeed, you may want to go down a whole other development thing that you don't want anybody to see because you're experimenting and you expect to break things. And there's multiple ways to do this. Remember this branch concept that I mentioned? Branching is the way to do that, but we probably won't get into that today. All right, but now what I want to do is I have these changes that I've made locally and I've committed. In other words, I've said, okay, yes, I meant it here. Now I want to push these changes to the remote repo. And the way I do it is I say git push origin. That's here is called the origin master. Master is the name of the branch on the remote machine. Now, I don't expect you to. I don't expect you to actually understand this. Just remember that magic git push origin master. That's 99 times what you're going to end up doing. And then one day when you learn how to do further branches and this sort of thing, you'll look it up. You'll figure it out. In fact, it's easy enough. If you had another branch named John, you'd say git push origin John. So, but we haven't. I'm getting ahead of myself here. So now I do a push. Gives me a ton of information there, most of which you can just glaze your eyes over. But one of the things it did say is it said, oh, you push 3 lines to blah blah this whole thing, which means the GitHub thing, and there it tells you what the name of this commit is. So now, if we look here, now suddenly we can see, voila, we have hello.python. And here's this code, this brilliant code we made. The other thing we can do is we can actually look now and take a look at the actual changes we made in the last commit. I'm sorry. Yeah, so...
Are those hex addresses?
No, they aren't. I'll explain those in 2 seconds. So look, and you can... This is... that's a good question, though. Actually. They are hex. But let's show... No, it's a good question. And I wondered about it for a while, actually.
Oh, also, I was wondering what those... Because I noticed that when I was looking at GitHub, what the hell are those,
this stuff?
@ signs? Yeah.
Okay, so, well, let me go through what's going on here. This is what you would call... This is the actual record of the commit. This is actually the edits you did between one step and the next. You can see that there's... the green indicates stuff you've added, and there's also a plus sign in front of it. The red would indicate stuff you deleted. There'd be a minus sign in front of it. Now, as Ray's asking, what's all this grayed out stuff here with the ats and all this sort of stuff is? It turns out that this file you see is actually called a delta, or a diff file. This is an actual text file, and you could actually store that text file and then use it as an operation to apply to somebody else's work. So and there's this form of diff files is universal across all version controls, well, modern ones. So all this you don't have to ever worry about this is the thing. But what this says is there's enough information just in this file you see here to replicate the changes you made. So this is really saying where in that file you made a change. Let's make another change here. Now I'm going to say, okay, we have, we have test, what did I call it? Oh, hello.
Is this Emac?
This is in fact Emacs. Okay, so supposing I change it to goodbye, whoops, didn't want to do that. Goodbye, cruel world. Okay, so now when I run this thing as Python, you can tell I'm very lazy. Hello, and now it's going to say goodbye, cruel world. Fair enough. So we can now take a look and see what's going on. First we say git status, and you can see now it says that we've modified that file. So last time it said new colon there, now it says modified. Notice it says changes not staged. So and all of this is actually pretty understandable. Changes not staged for commit means I have made this change, but I haven't said, okay, this is the change I want to commit. The one way to do that is again git add dot. You're going to find yourself doing git add dot, which means all the changes in the directory I'm sitting in, I want to commit all of those.
Comma, then the next
Yeah. Well, not even comma, but just you'd have to list all the files. Very annoying.
Okay.
Now I'm going to do git commit again, which means yes, I want to commit. I want to commit. All the changes with this message. Now I'm glum. That's the message here. And then we do git push origin. That's us. Master. That's the remote branch. I know I'm almost done with this. I know it's a tiny bit dry, but it's a really helpful way to work. So here we go. And now if I refresh, oops, wrong button. If I refresh, we can see, we have a new commit number here, and I'm going to tell you what these are in a second. Look, it says, you can see now it actually tells you when each file was changed. It says, git ignore was checked in the initial commit. Now we have but hello was changed in this commit called now I'm glum. So let's take a look at that commit. We're going to click on this file, and you can see here that the minus I removed the line saying hello world, and I replaced it with goodbye cruel world. So it shows you where each change occurred. Really, really, really handy. And particularly it's handy when you're, as I said, when you're trying to figure out what you have done wrong. It's also handy if you just decide, I didn't want to make that change. It's very, really super useful. Now, here's the question that you asked. What are these funny numbers here? What's going on here? Well, here's the thing. Remember that this is a distributed code system, right? So you and I can be making changes at the same time. But you need a name for each change, for each commit, has to have a unique name, right? Otherwise, there's no way to refer to them, right? So, and any change I make on my machine needs a unique name, and changes you make on your machine need a unique name. But wait a second. I don't even know you may not be on the internet. I have no way. I don't even know that you've cloned. There's no way for me to find out that you've cloned. You may have secretly cloned this and be making secret changes. Or whatever it is, or you could be offline, or whatever it is. There's no way to know what you're doing. So how do you deal with this? Well, the way they do it is they create a random name for each commit, and the random name is an ultra long string of hexadecimal digits, so long that the chances of duplication ever occurring are 0. I mean, the mathematician within me says they're not 0, they're just so small that you're much more likely to drop a pencil and have it land on the end and balance. So here, let's show you here's a full name of one of these. This is the full, by long I mean that's the full name of the commit there. D63C81, really, really long. And that guarantees uniqueness, and that's a very nice thing, because it just means we can work independently. When everything gets put to the repository, there's another one of these numbers generated, and that one becomes the commit, the name of that commit in the repository. You never ever have to memorize these things. In fact, if you look, a lot of the times they only just quote the first 4 or 6 characters, because nearly always within one project, the first 4 or 5 of these things are unique. So, and one of the nice things about GitHub is you don't have to paste the whole thing in. You only have to paste in the beginning. whatever's unique, which is often the first 4 or 5. So that's why you can see in this case, this is the first 8 of those. That one should be huge. That should be more than enough. There's one more thing I was going to say about this. Oh, so okay. So there's great things you can do here. Let's go and edit one more time. Okay. Let's go and edit this thing, and we're going to say goodbye, cruel world. But I'm going to add a mistake to this code. And if I try it now, Python import hello, we're going to get an error. Syntax error. Oops, because you can see I added an extra quote there. Okay, but let's supposing I'm stupid and I didn't notice this. And in a big project, you see, you may not be able to test everything. There will be bugs appearing. There will be bugs appearing. But let's do it anyway. I'm going to do git commit -am. This is new, slightly new. Add a deliberate bug. Alright, so -a is another way to avoid git add dot. It just says commit all the changes you have. Commit every change you've made. So this, I find I'm doing this one line a lot. Now remember if there's other files in there, new files, each new file has to be explicitly introduced to Git. Git add dot does that very well. If I added a new file here, like let's do this.
Oh, so I'm sorry.
Yeah.
To interrupt. Git commit -am basically gets rid of the add dot step.
That is, but here's the thing is,
so you don't need to do that if you do that.
Well, here, that's not entirely true. Here we go. I just created a new file here. In fact, let me quickly store this for a moment, and let's do. So you can see I have a new file here called Wombat. Unless I do git add dot, new files won't be added. But AM will change all existing files.
Got it.
And that's why, and that turns out to be totally convenient, because a lot of times you don't want to add new files. You're playing with them. You're just experimenting. You just want to add the changes you've already done.
Right.
Really, really convenient way to do it. So let's do. So we're going to go back and do this one. We're going to add a deliberate bug, and now I'm going to make another change. Now I'm going to do git add dot, which will add that new file Wombat, and I'm going to do git commit -am. Add a new file wombat.py, and then I'm going to do git push origin master. Fine, but oh dear, I have introduced a bug deliberately, right? And we can go back here and we can see. Actually, let me go to. Now I'm on a bigger screen. So I'm going to go back to here, and you can see we have the new wombat file, and you can see that the bug is in here with the quotes. Okay, but now this is easy to find here, but you may have tens, hundreds of thousands of lines of code. Figuring out where the bug was difficult. Well, Git has this amazing thing, and I don't expect you to remember this, but it's good to know, called Git bisect. Let's hope I can get this right. I'm gonna let's bisect. I did this, so let's take a look. Great. Okay. So what bisect does is literally do a search, that you search through your code, the variations of your code, to figure out where the error occurred. What it does is by bisecting, in other words, you say, okay, I know this check-in was good. I know this check-in was bad. So what's the check-in halfway in between those? So you go, you look at that, you see if it works. If it works, you mark it as good. If it doesn't work, you mark it as bad. So even if you have thousands of changes in between, each time you cut the number of possible changes in half. So it's an incredibly good way to go back and find, how I made a terrible mistake. So let's try it out. Here we go. We say git bisect bad. Oh, sorry. You see, I forgot. Git's pretty clever. So I forgot to say git bisect start. And it says, you need to start by git bisect start. Do you want me to do it for you? I'm like, yeah, thank you. That's very kind of you. So there we go. So now I've started the bisection process, and I've marked this current state is bad. Now I'm going to look at the initial. Let's go back to my my commits, and you can see we have a list already of 5 commits. Right? So each of these is a tiny, tiny change I made in the code. So let's go to this commit here, and this commit is 10 blah 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 blah, and we know that one was good. So let's say git bisect good this guy. Notice I only kept. So now it's in bisecting, right? One revision left to test after this, so it's already gone, and it's already said, okay, now we're in this huge change, D63 blah blah, which corresponds to now I'm glum. So you can see it said, okay, this is a good change, this is a bad change. I'm going to split the difference. Is this good or bad? So we go check it out, and I do Python. What was it? Hello.py. Worked fine. So that's good. So I do git bisect good. I say it's good. Now it picks. Now it actually says, okay. Now it picked the one in between them. That's 6, 4, 5. And if I take a look at that one, that's this one here. You can see, well, you can't see it there, but because it's too small. But it is actually picking this one. Now I try it out, and I say, let's do my test. Python. Oh, I get an error. So I go git bisect bad, right? And voila! It's actually just like said, okay, well that has to be the bad one. So it figured out where the problem was there. It's even created a change for me to revert it if I would like.
So wait, it doesn't actually make the change?
Well, how can it? I mean, particularly as you may not want to. There may be thousands of other changes later on that you want to keep. That's the point.
So let's say you're able to figure out the bad commit.
Right.
How are you supposed to take this information and then get rid of the bad commit?
Very good question. I mean, one simple way is, now I found out. Oh boy, I hope that wasn't expensive.
Nope.
One of the things I've discovered from here, which one of these is, so I can actually just go and read that file, read the change. Mm-hmm. Oh look, I added that quote and it failed. Another way is that I can merge. There's a whole bunch of different tools. I could just say, okay, let's take this file the way it was there. I can apply that diff. I can actually you can see that this thing is a diff, as I said before, with all the @ signs. You don't care about this, but there's a way to apply that and say, okay, undo just this one tiny change on that one file. Mm-hmm. There's a ton of ways to do that, but typically what happens is I don't find. Typically I just never do this because. Most of the time, because I'm keeping my changes tiny, it's some tiny thing like this. Yeah. So I can make the change in what's called the head. So let's actually take... Now, the thing is that now I'm sitting here. If I take a look at where I am, I'm actually... so it says very clearly what's going on. Head is detached. What does that mean? It says, you're currently bisecting, right? We're doing this whole bisect thing. We started from branch master... So we're actually in this kind of special bisect state where we're doing this thing. So now I say git bisect reset, because it just tells me to do that. It makes sense. We're resetting the whole process. Reset. Voila. So there we go. So we just added that bug, but now I know where the bug was. I can see it's here. So now I just take a look at hello. Yep. Oh, it says, yeah. And now, voila. Save it. And now I can do git commit -am fix the bug, git push origin master. I get it. Should have tested it. Right. So there's several things that can happen as well now. John could be working on the same repository and push while I'm pushing. Well, what happens? Well, one of the things when you're working with multiple people is there's a reverse way to get information. And I was intending to actually go through this whole, but I think we've done enough on this and it's not actual programming. So ask me if you have problems with this. But one of the things you need to do is if somebody else is pushing to the repo, you need to pull from the repo. Right? The reverse thing is. So you should be pulling quite a bit when you're with other people. But that's going to happen that you're in the middle of doing something and then you go to check in and somebody else has already checked in. That's fine.
Do you always need to do that reset hard head thing?
No. What reset hard head? Let me get to it. Stack that question. Sorry. When somebody else is working and you're working, often they've checked in, and often you can't just reconcile what you're doing with what they're doing. So what there is what's called a merge, where your changes and their changes are merged together. Now, Git's pretty smart. A lot of the time, it can actually automatically merge the code, which is really, really handy, because it knows that. I should add that you should always look at. It'll do it for you automatically, and I'm not going to go into this now. I think because it's taken too long, but again, there's great tutorials, thousands of tutorials at all levels online for this. One of the things is it does emerge so well and so easily, you're very tempted to just let it do its work and never look at it. Don't do that. The reason is that even though the merge may, sometimes it can't guess what you mean, and it turns out that the merge isn't, in fact, exactly what you want, because... but in some cases, you can't actually merge properly because your change is right in the same line as somebody else's change is. Even then, there's a bunch of tools that you have. In fact, there's like 5 or 6 possibilities called merge tools that let you say, okay, well, for this change, I want my change. Oh, for that change, I want his change. Oh, for this change, I don't want either of them. I'm going to type something else in. So it gives you absolute freedom to do this. And yes, merges are a drag. Don't get me wrong. It's so easy to break things when you do a merge. Sometimes merges have subtle problems. But that's what happens in the real world when 2 people are working on the same file at the same time. It's just an intrinsically hard problem. And there's a limit to how much you can simplify. At least you have tools to deal with it. So I think that's it. So Git is it's a distributed version control system, not a centralized one. It gives you a way to share changes between multiple groups of people, or even on my private projects that no one else sees, I use GitHub and I check in all the time. And it's because, I hate to piss my work away. My machine goes down, oh my God, but no, I've checked it in. Not just that is, bugs are really nasty. I hate bugs. It takes far longer to fix a bug than it does to write the code. So what I typically do is I make tiny changes. I check everything out. Then I check it in. And then I make another tiny change. If I make that tiny change, I test it and it doesn't work. I look at it for about 1 or 2 seconds. Well, not that long, but I look at it and at least see if I can figure it out. If I can't figure it out right away, I instantly revert. Now, here's the answer to your question here is...
Right.
So what happens if you made a change you don't want? So in other words, I'm here, and I'm looking at this thing, and I do this thing, and oh, look, the cat got on my machine. Oh, and I saved it. Oh dear. Oh, in fact, I actually...
made legal code.
Oh yeah, well that's no, it's not. So there we go. So I saved this. Oh dear, terrible mistake. Well, how do I do this? The answer is you'll do this quite a bit. You do git reset dash hard head. And like a lot of other things, you kind of just need to memorize this. I could explain you all the details, but you don't have to. And you can see that the file now is back to where it was before. Very fucking handy, excuse my French. So, so one of the key things about this is, as I said, it makes for a much more relaxing workflow. You make tiny little itty changes. And then you test one, and if the change doesn't work, I look at it for 2 seconds, I'm like, no, I'm going to do it again. I just throw it away. And the advantage is, because I'm making such tiny changes, I lose very, very little work. And I'm always in the thing where if I'm suddenly, if whatever, the ceiling falls in or whatever it is, when I come back to my machine, I'm in a known good state at all times. So I can't overestimate the value of that. Now, here's another question. What if you check in my mistake is? Well, I'm not going to go into this now because I'm way over time. But there are tools, there's Revert, all these other tools that will let you say, okay, I didn't mean to do that last change. I didn't mean to check it in, so let's undo all that. All of these things are available for you. It lets you have complete control of your workflow at all times. So I use it even for private things. And one of the other nice things for you, John, you're actually making changes, is even if you can't check your proprietary code in outside the company, and they may not have a Git repo for you.
Not yet, but they will soon.
Oh, well, they will soon. But the point about it is it's a distributed thing. So if you just install Git locally on your machine, you can do all of this stuff without a foreign repo. All of it will be there. And a lot of people at Google, they had this system called Perforce that runs at Google, but it got very, very slow. The Brazilian people, literally, they would check something in and they would be like a minute to change it, to do tiny changes. Plus is... it's a locking system, so when you take something out, other people are locked out. So it's particularly bad for the poor Brazilian people because everything's taking minutes to do. So they actually figured out a way to run GitHub on top of Perforce, and so they could make tons and tons of changes, and then locally, and then finally, when they got access to the very slow main thing, they could actually send their changes off one at a time to that. Really, really handy, and they did this without any... Well, Google loved it, actually. They incorporated this, but they didn't need to change anything for anybody else. Nobody else knew they were doing this until they revealed that they had done it. They didn't have to bug anyone because it's all local. So I do this for everything. I do this for when I'm writing text documents. Like when I'm writing Microsoft Word documents, I do this now. Admittedly, the deltas aren't so clear on a Microsoft Word document. There, when we saw those deltas, that's the name for this thing. That's a delta. with the pluses and minuses and all this sort of thing. The deltas just aren't very clear for things like Microsoft Word documents. But it's fine. The point is that I just have everything I've saved. If I whoopsie a paragraph and don't notice it, it's back there. I can go and just get to the other spot, copy it, go back to where I am, paste it. It's like an instant backup of everything you do. So you use source control for everything. Great. Questions?
Let's just, if you don't mind.
Yeah.
If you just type history, just so I can remind myself
Absolutely.
of all the commands that we just saw. And so I'm seeing that there's an add,
Right.
there's commits, and there are pushes.
Right. There's also status.
Right. But
Git status, and you'll see now here, let's do this will be an empty status. Nothing to commit, working directory clean. Now if I did something like, let's do touch fools.py, then if I did git status, it knows, look, so it's very clear, it says there's nothing committed, but untracked files are present. Use git add to track. Very nice and clear. You have to admire messages like this that tell you exactly what's going on, and go a little extra further. Oh, you might want to commit this thing. So very nice and clear.
just so that I can be clear, though,
Yeah.
on the differences between add and commit. Add adds a file, but what does commit do to that?
So
file?
basically is you're always preparing a commit. You're always preparing to make sets of commits. So basically is you make changes. You say, okay, I want these files to be in this commit. So add gets ready to make a commit.
So
the
put it
term
in
is
a queue.
stages.
It puts in the queue.
It's not really quite a queue because there's only one. It's like a queue with one element. But it says, when you do git add, it says, okay, stage this for the commit I have. So there's this, and again, it's like, oh, why do I need this extra step? Because otherwise you'd constantly be fucking up. It's only one extra step, and it means that, okay, you make the changes, you say, I want these changes, let's glue them all together. And in fact, if you just do git commit without anything, it'll actually bring up VI, probably in your guys' cases. And you'll have a list of the files, and you can just move them around and this sort of thing. So there's an interactive way to do it, but, which is good. I mean, except I just didn't show it because I wanted to show the nitty-gritty. So, yeah, so the commands we have...
And push.
Right, so pushes the changes, the last commit, or all of the last... You could have many, many commits since the last time you pushed. Pushes it to a remote repository.
I see.
Now, unlike most other systems, that remote repository does not have to be anything special, right? It doesn't have to be like... There's no single godlike source of truth. That's the computer term you say. There's a single source of truth. No, that doesn't happen in GitHub or Git or Subversion or Mercurial or any of these other ones. They're distributed. There is no center. There is no source of truth. So he and I could be working, and I could push right to his machine. Well, except that the reason we don't do that, people don't do that more often on the internet, is identifying his machine might be tricky. Right, he's probably got an IP address. There's probably a firewall in between there that prevent it. So that's why another reason for using these intermediate things. So pushes to any other remote repository where I have permissions. Pulls from any remote repository where I have read permissions. Resets gets rid of all changes that haven't been committed yet. And then there are other changes. If you want to get rid of changes you have committed, even changes you pushed, there's a whole set of tools. Revert. There's a couple others, but we won't do this. So that's kind of how it works.
Okay.
Cool. So that's Git. So we're in something. Let's get rid of some of these guys. Fools. Let's get rid of that. They're all kind of boring. So get rid of these. Oh, in fact, let's commit this. And in fact, look, I have a script that does the add, the commit, and everything. I said rid of craft. You know what that word means. Voila. So it got rid of everything there. And if we went back to here, we could just see, voila. Oh, there we go, and you can see we're back to hello.py. Okay, so now let's take a look at, we're going to do now very quickly the things that I didn't quite cover before. I'm going to do quickly two tiny things. One of them is the elif command. Terrible name, I didn't do it, but there we go. And the other one is exceptions. Let's just do exceptions. Let's do elif first because it's dead easy. In fact, I don't even need this. Let's go to the shell. And I'm going to just start with Python. So I can say here, No, actually, it's probably easier for you. Easier for you to read here. Let's go for easy to read. So I'm going to do def goodbye, very dull name, and I say goodbye of x. I say if x equals 2, print I am 2. If, here's the new command, x equals 3, print I am 3. Else, print, oh no, let's do double quotes, I don't know what I am. I use double quotes because I'm using the single quote in there. Voila. So if I go back to the shell, now we can see we're going to do import hello.goodbye 1. It's going to say I don't know what I am. 2, and 3. So basically, this should be pretty straightforward. Basically, it's just an else if command. Else if, right? And you're like, well, in this case, it doesn't really make a difference. I could just have if there because I know if x is 2, then x is going to be equals 3. But sometimes there's a series of conditions you want to test. Like a classic thing you often do is you say, this is a classic thing you say. If not x is empty.
Right.
Elif length x equals 2. I am length 2. Elif I'm length 1, right? So, oops. So I'm going to do reload. If you remember the reload command, reloads a module here, and then if I do hello.goodbye, and I do just something like none. Remember, none is that special object that does nothing and is falsy. If you recall, falsy is something that means it looks like false. So if I do hello goodbye none, it says this is empty, right? So it does if not x. Now, if I didn't have the else if I tried to take the length of none is going to be an error, right? It's going to say type error because it has no length. It has nothing. The whole thing about none is it has no operations that are legal to do on it. But so goodbye still works if I do because then if I can do here. Right, so if I didn't have that else if, that elif there, it would try and take the length of none, it would fail. Anyway, I think I'm overstating this point. I think you all understand how elif works. Very straightforward, else if, voila. Okay, so so that's else if. So we have one more thing and then we'll take a tiny break and then you can prepare your questions and conceptual things. The final thing we have is exceptions. So let's do def print length of y. Okay? So what's going to happen here? We want to print out the length of something. But what if it's none? What if it's the numbers? Numbers don't have a length either. How are we going to handle this? So, let's take a look. Let's just start. We'll start off by saying first we're going to print length y. So we're going to do we're going to reload hello. We say hello.print length length. Let's try it. So 1, 2, 3. That's going to be any guesses?
3.
3, right. So prints for length of that. But if I do print length 1, I get a type error. Object of type int has no length. And again, Python errors are pretty good. There's a lot of stuff in them, but again, never freak out. At least try and read through the error and figure out what it says. And then, if you can't get it, search for the beginning part of this thing. And online, you'll find somebody's explanation. It's really nice. All the errors are really well set out. And again, as I can say something, print length none. We don't want this. Particularly, in fact, I may want to say print. That's 1 second. Double quote. That's all, folks. So I may want to do something. I may want to do something afterwards, like say that's all, folks. But of course, because there was an error. The thing after that print length there doesn't execute because you try and print that length. Oh, it's an error. It dies. So all the rest of the processing fails. That's bad. Often you don't want to do that. Often you want to recover from errors. Exception handling is the way to go. exception handling is the way to catch errors. In fact, these aren't even, they're actually, even though some of these things are called errors, the generic term for all of these is exceptions. And what happens, why they're called exceptions, is because they're an exceptional condition is occurring. Something that's not what you expect to happen. And there's many, many different types of errors. Now, but let's just start without getting into the type. And you can tell when you get the error message, actually the very first thing it says is what type of exception you're getting. This is a type error. So let's just start without worrying about the type of the error. I'm going to say now, try. This is a keyword, one of the few keywords in Python. It says, try to do this next thing. Notice I indented this. It's another scoping statement. And then we have except print, oops, no length for you. Okay? So let's just reload this. And then we're going to do hello print length none. Oops, no length for you. So here's what happens here. It tries everything in that block, that try block. If an exception is thrown, here's how the terminology works: is you throw an exception. Somewhere else you catch that exception. You probably heard that one coming, right? So when I try and so the except clause is what actually catches an exception. In this case, I just say except, and that catches all exceptions. I'll show you in a second that you can catch only some exceptions, which can be very, very handy. But in this case, we're only going to catch one. And in the case there where I'm trying to get the length of none, it tries to print the length of none, but that doesn't work. That throws an exception. So then it jumps to the except block, and that's called so it catches the exception there, and then it prints out, oh, no length for you. And then it keeps going. You see it says that's all, folks, at the end. So it does successfully do this. Now, what happens if there is a length? Let's do something like print length A, B, C, or A, N, C, or whatever. Right? What happens there? Well, it prints for length. The except, in this case where there is no exception thrown, the except clause does not go off. It only goes off if there's an exception. Mm-hmm. Okay? So I don't know why this was barky today. Sorry about that. I'll go be nice in a second. So it's really straightforward way, and it's really, really handy. Now, one of the things you can do is you don't actually have to. The exception can be thrown at one spot and caught much, much higher up. You don't have to throw and catch the exception in the same function. Let's try it out. Let's do. Let's try. Well, I need a better name for this. What did I call it before? Let's call it print 2. This is so boring. So let's get rid of the. Let's get rid of this. All this exception handling. Right. So now I'm going to say try print length y. Oops. All right. So now in this case here, let's take a look at what we're doing here. In fact, let's get rid of hello and goodbye because they're boring. And here we go. So we have this simple function print length, but that function may throw an exception in there. That length thing may throw. And let's do print. Let's just do this print and end of print length. All right. So here's this little function, but it may throw an exception. So here I am now actually going to catch the exception, but the exception isn't generated right here. It's actually generated inside there. So in other words, the error isn't occurring on this line. It's occurring inside that function. This is where the error occurs. Mm-hmm. So here we go. Error. Right? So, but this will all still work. This will all still work perfectly well. I'll do reload hello. By the way, that error you see there, connection to GitHub closed by remote host, I did something too fancy and I keep getting that error popping up and it's not helping me out. So, yeah, I'm just pointing out there. Yeah, don't people at home don't expect to see those errors like that. If I hadn't done something stupid, it wouldn't be there. I should fix it up. So now if I do hello.print length none, we're gonna get an error. doesn't get to that end of print length. So now let's do hello.print2 of none. And you can see it says, so what happens here? Within this try block, it tries to print the length. So it tries to do this, and this throws an exception. So immediately, notice that this line, end of print length, is never printed out here. Why? Because immediately this exception is thrown, so it jumps out of here. But then that exception is caught at one higher level. And then it says, oops, no length for you, and then that's all, folks. So on the other hand, if I did something which did have a length, like ABC, well, I can't really type those. So then it does. It prints 4. It prints end of print length, and then it prints that's all, folks. So that's one of the. So you can, and this is called propagating exceptions. Lovely name, and I like it. Propagating. It's like some sort of, and and the thing about it is it works exactly the way you'd kind of expect. An error deep down somewhere is thrown. It percolates all the way up, so each function fails as it gets this exception until it reaches an exception block, like this. Now, one of the things you can do is you can actually say, you can also say except type error, right? And so what happens is this means only catch one specific exception. It's still going to work exactly the same. Oh, actually, we just do the one that doesn't work. It's still going to work exactly the same as the previous one, because that's a sort of error. But there's, but the point is, what this lets you do is only catch errors that you're expecting to occur. There's another one called value error there. So if I do this and I say here, oh, it doesn't catch. It doesn't. So this except block now no longer catches the type error, because it's only expecting value errors. You can also make and this is very handy in my code, for example. I have, like, when you try and enter some value that you don't understand, I give you a prefix error that I made up. All through the code, I'm catching prefix errors. But I don't want to, and then saying something clever. But I don't want to catch other errors. Other errors mean I made a programming mistake. I'm not expecting those, so I don't catch any of those. I catch prefix errors everywhere. The other ones just percolate to the top. It dies because I want to know about those. I'm like, oh, I want to see this die. In fact, you can see occasionally in my earlier code in this big project I'm working on, that I didn't do this. And sometimes I get really, really puzzling errors, or even no error at all, because I'd catch something I expecting to happen, but no, I was catching too many errors. So I created my own type of thing called a prefix exception. Catch only those. Now my life is happy. When I get an error, I can now tell the errors I'm expecting to happen. A prefix error just merely means, oh, you type, instead of element, you type element or something. So it can be very clear, and everything else I don't catch. Who the hell is this? No. God, you call me too much. Okay. Right. Again, I think it's a pretty straightforward idea, but you should know about this, and it'll be very, very helpful when you write production stuff.
This could, potentially make, long if statements or while statements a lot shorter. Right? Absolutely true. Yes. Absolutely. That's a classic thing you do, typically one of the things, in fact, I have some examples in your code, but we'll get to those later, it's a much better way. That's one of the things they say is, there's a classic Python joke, you should seek forgiveness, not permission. You probably heard this before in the real world. People say, it's better to seek forgiveness than permission. In other words, go off and do something and they, I'm sorry, rather than asking permission you're not going to get. Well, the way it works in Python is, for most things, particularly things that don't change the world, you don't want to use your CNC router. Do you know what those are? Those laser things that do cutting automatically? You don't want to go off and make a mistake and be like, oh dear, I blew your eye out or something. Or I destroyed this vital piece of stuff. But most of the time in Python, instead of checking to say, oh, will this actually work if I try to do it? You shouldn't do that in Python. You should just try to do it and catch the exception. That's what I mean forgiveness over permission is. Don't bother to check to see if something's the right type. That's a terrible thing. Whenever you see people, almost always when you see people in Python checking if something has the right type, they have made a mistake. You don't do that. You just barge ahead, and if there's an exception, you catch it and fix it. Much, much better way to go. Because the thing is, supposing you say, oh, I want this thing to be a list. Well, later on somebody passes you a tuple, and you're like, oh, actually that would have worked. Or somebody passes you a string, you're like, oh, that would have worked too. You don't do this. You just try and do the operations you need.
And in fact, this is all keeping with something, a tiny aside, but it's pretty funny, is one of the things that Python relies on is what's called duck typing. Duck typing, I mean duck, as in the bird. And what duck typing it means is, it comes from the expression, if it walks like a duck and it quacks like a duck, it's a duck. So other languages require you to make heavy use of inheritance for a lot of their things. And Python doesn't do that. If I need a method called run on a class, in another language I'll be required to have a special runnable type, and all the things that I want to do that run I have to inherit from that type. In Python, no, I just need to put a method called run on my class, and other people will call that method, and they don't care about inheritance. All of the thing is, that's what duck typing is. You just try and use the function, and you don't care about what the actual type is, and if it works, it works. Great, it's a real great time save. It's conceptually much, much simpler. You just don't, none of this fascination with types and this sort of thing. All right, time for a break, and then we'll go back and, pause it, please.